Okay, let's look through some particular examples. So this says, use the binomial theorem to calculate the coefficient of x to the power of 8 in 1 plus x to the power of 12. Okay, the first thing I note is that the power is 12, so n is 12. And I want the coefficient of x to the 8. Now let's start off with the general term, expression for the general term for 1 plus x to the n, which is NCR x to the r. If I want x to the power of 8, that guides me that I want r to be equal to 8. Okay, so if r is equal to 8, I get that the ninth term is going to be, subbing in n is 12, 12c8 x to the 8. So that'll be the ninth term. That'll be the term that has x to the power of 8. We want the coefficient, so the coefficient of x to the 8 is going to be equal to 12c8, okay, which is 495. Okay, so you can see using this NCR is very, very powerful. Imagine it writing out Pascal's triangle all the way out to the row that starts off with 112. It would be a huge triangle, so this NCR is very helpful there. Alright, let's find the term in x cubed y to the power of 4 in x plus y to the power of 7. The general term of x plus y to the n is given by this formula that you should memorize. Now the key thing here, n is going to be 7, that's your power. You have to think what r value you're going to use to grab this particular term. I think the easiest way is spotting that's y to the power of r, and we want y to the power of 4, so we want r is equal to 4. Okay, substituting in, we get t5 is equal to 7c4 x, and then that'll be 7 minus 4 y to the power of 4. Simplifying, 7c4 x cubed y4. And 7c4, if you put in your calculator, it's 35. So that there is the term in the expansion of x cubed y to the power of 4. Okay, let's do one where we substitute things in. So it's not just going to be x and y, it's going to be something different. Okay, so we've got 2x minus 3y to the power of 12. Okay, first thing I notice is that n is 12. Okay, I'm going to replace the x in the rule by 2x and the y by negative 3y. Okay, so fourth term, so that's t4. So let's start off by writing out the general term. Actually, I'll just substitute straight in. So t4, if it's the fourth term, r plus 1 is 4, so r is going to be 3. Okay, so n is 12, r is 3. Let's substitute in. So we're going to get t4 is equal to NCR, which will be 12c3. And then the first bit, which is the 2x, I'll put the 2x in brackets, to the power of n minus r, so 12 minus 3. And then the second bit, which is going to be negative 3y, and note I include the negative here. Negative 3y raised to the power of r, which is to the power of 3. So that's my fourth term. And now what we can do is we can simplify a little bit. It's negative raised to an odd power, so the final answer for this term is going to be negative. Okay, you can simplify the powers if you want in your head. I'm just going to jump straight to the answer. So in my calculator, I put 12c3, 2 to the power of 9, 3 to the power of 3. And when I did that, I got an answer of, it's a big number, 3041280. Okay, x will be raised to the power of 12 minus 3, which is 9. Y will be raised to the power of 3. So that's the fourth term there of that expansion. Next, B. Find the coefficient of x to the power of 10, y to the power of 2. Okay, I can see that's y to the power of 2. That's going to guide me to use r is equal to 2. So for B, we're going to use n is 12, r is 2, and we'll get the required result. So basically, using this formula here for the general term, it's going to be T3 equal to 12C2, the first bit, which is 2x in bracket, 12 minus 2, and then the second bit, which is negative 3y raised to the power of 2. Okay, it's a negative raised to an even power, so the answer is going to be positive. Okay, if you want, you can simplify a little bit in your head. It's 2 to the power of 10, x to the power of 10. It'll be 3 squared, y squared. Okay, so in your calculator, you would put 12C2, 2 to the power of 10, 3 squared, and you get a big number, 608256, and then that's going to be x to the 10 y squared. Now we're after the term or the coefficient. We're after the coefficient. So the coefficient of x to the 10 y squared is equal to 608256. Okay, next one. So first bit in bracket is 2x, and the y term here is like 1 on x. Okay, the n is 12. So I'm going to note what the n is. N is 12. I'm not quite sure what r value to use here yet. Okay, so it says find the term independent of x. Okay, remember, if it says independent of x, that means the constant term or x to the 0 term. Okay, maybe let's start off by writing the general term. General term. So TR plus 1 equals to NCR. And I'll sub in that n is 12 immediately. So let's go 12CR. The first guy, which is 2x, n minus r, or 12 minus r. The back guy, which is 1 on x raised to the power of r. Okay, if x appears in multiple spots and I want something to do with power of x, I'll use index laws to combine these. Okay, so what I'm going to do is I'm going to bring out all the numbers out the front. Okay, so that's 12CR, 2 to the 12 minus r, and then I'm going to put all the pronumerals at the back. So that'll be 12 minus r, and that'll be x, because that's 1 on x, I'm going to make that x to the power of negative 1, so times, and then there's an r there, so we get, using index laws, we get x to the negative r. Let's simplify, combine these x's together, and then we'll be able to work out, once I've worked out that general term, I'll be able to work out whatever power of x I want. Okay, so we've got 12CR, 2 to the 12 minus r, and because we're multiplying, we add the indices, and if I add a negative r, that'll become 12 minus 2r's. Negative r plus negative r is negative 2r. So that's the general term. Okay, so we want the term independent of x. Okay, so we want the x to the power of 0 term. So therefore we want 12 minus 2r, that's the power of x, to equal to 0. Okay, so solving this quickly, you'll get that r is equal to 6. So we're after the term where r is equal to 6, so let's work that out. So T7 equals to 12C6, 2 to the power of 12 minus 6, and then that'll be x to the 0, because we're making 12 minus 2r equal to 0. Okay, so the term, the independent of x, is the 7th term, and that's just going to be 12C6 times 2 to the power of 6, and if you put that in your calculator, you should get 59,136. Okay, so that's A done. Let's do B. You'll see why the general term is quite useful here, because it's now asking for another term in the expansion. Actually, it's asking for the coefficient, x to the 4. So we want the power of x to be 4. So having a look at the general term here, that means that I want 12 minus 2r to equal to 4. So I'm going to work out the r value here. Okay, so rearranging, you get that r is equal to 4. So therefore, the term will be T5, because R plus 1. Let's substitute in R is 4. We'll get 12C4, 2 to the power of 12 minus 4. And then that would be X, and because 12 minus 2R is equal to 4, it'll be X to the 4. Okay, that's the term. We want the coefficient. So the coefficient is just going to be this. So coefficient of X to the 4 is going to be 12C4, 2 to the power of 8. Okay, into your calculator. And if you put that into your calculator, you should get 126,720. That's the coefficient of X to the 4. Okay, one more question here. Find the general term of the expansion this. So first thing I noticed that n is equal to 20. The x value is 2x all squared, and then the y value, remember if it's a negative you put plus and then negative. So the y value is negative x to the negative 1, or just 1 on x. I'll leave it like this. Alright, so let's do this. So the general term, we're going to use the formula TR plus 1 equals to NCR, and I'm going to sub in the n value straight away. 20CR, the first guy, which is brackets 2x squared, always put brackets there, raised to the power of n minus r, so 20 minus r. And then the back guy, which is negative x to the negative 1, raised to the power of r. Okay, so what we're going to do now, usually we put the numbers at the front and the letters at the back. Also, a trick that we often use when there's a negative is that's a negative 1 to the r. We often bring that negative 1 to the r out the front. So let's do this. So negative 1 to the r, that'll come out the front. That's this bit here. Then we've got 20CR. I've got 2 to the power of 20 minus r. Then I've got an x. Now I'm going to multiply these guys together because I'm using the index law. So that'll be 40 minus 2r. I've expanded immediately. I've multiplied them out. And then that's x to the negative r times by r. That'll be x to the negative r there. Okay. So that's dealt with. Okay, so let's keep simplifying. So that's negative 1 to the r, 20 CR times 2 to the 20 minus r. Index law for the back, so we combine, so we've only got one x term. That'll be x to the 40 minus 3r. So that's the general term. Once you got that, you can pick out a term in any particular power. So part B says find the term in x to the negative 5. Okay, what does that mean? I need to set the 40 minus 3r equal to negative 5. So we want, for part B, we want 40 minus 3r to equal to negative 5. Let's rearrange. Negative minus 40, that'll be minus 45. R is going to be 15. Okay, so therefore we want the term, so T16, let's sub in. We're subbing in R equal 15. Negative 1 to the 15, 20C15, 2 to the 20 minus 15, and then that we know is going to be x to the negative 5. Okay, a negative 1 raised to an odd power is just going to be negative 1. Okay, so we've got 20C15, 2 to the power of 5, x to the negative 5. We want the whole term, so I include the x to the negative 5. Okay, let's put this in our calculator. We'd get negative 6,080 x to the negative 5, which is the answer. All right, good luck with the exercises.